and get started. As I've mentioned before, we'll be doing OverTheWire's Leviathan today, and what Leviathan is similar vein to Bandit, but a little more advanced Linux concepts. I wouldn't go so far as to call it debugging, but you do a little bit of binary analysis and some low level or basic like binary exploitation. No buffer overflows or coding or anything, but we will use some tools like ltrace. We might even pop into GDB real quick just to check something out. But yeah, so contrary to Bandit, however, Leviathan is not very well guided. If you go to the main page, it kind of gives you the setup and a quick overview where to SSH to and what the basic username is. But once you actually get into the levels, it's very much, there's nothing here. Whereas Bandit, was giving us places to read and cool stuff to look at and kind of pointing us along. This is very much on our own. So hopefully we can make it through. I think we will. In fact, I know we will because I've done this before. It's been 5-6 years now, but I think we'll be okay. So let's go ahead and hop in. Let's grab the address that we'll be SSHing to. And a couple changes to the stream. The first change is, if you follow me on Twitter, you'll know that I have officially given up on music for now. One of the copyright trolls has decided that Creative Commons non-commercial with attribution is not enough to satisfy using it in a stream. I don't know. But since I'm not a lawyer and I don't really want to fight it, I don't want any marks on my account, I'm just abandoning music in the background, so, light music. The other thing is I'm streaming at 1080p now. I decided that the screen quality is more important since we're following along with, terminal output and whatnot. 4 or 5 years ago when I was streaming video games to Twitch, that was problematic, streaming at 1080p because not everybody could stream, downstream 1080p. I think we're probably okay now. If you guys have issues watching it or anything, feel free to say something in the chat or comment on the YouTube videos. But for now, I think it's a positive improvement. So we'll kind of see as we go. But let's go ahead and log in. Let's jump right into it. And then the password to the first level is Leviathan 0. So here we are. And as with Bandit, and more so with Bandit more so with Leviathan than Bandit, we kind of have to feel our way through this. So we'll go ahead and just take a look at what's going on. A pretty clear indicator anytime we see something that we're able to read because of a group, but is actually owned by someone else. In the over-the-wire war games, those are pretty good indications that that's the direction we want to go. Plus, anything that's quote-unquote hidden, as we went over last time, that is not hidden, but anything that's got a dot in front of it is, something interesting to see. So let's take a look. And there's a bookmarks.html. Looks like a backup of somebody's web browser bookmarks. Just kind of open this up so we can see more. Looks like somebody's got visits this goshen.edu, Goshen, Goshen. I'm not familiar with it. Bartle Art as well. We could probably go through this a lot if we WC-L bookmarks. We're going to see that it's 1,300, almost 1,400 lines. So we don't want to go through those manually. What we probably want to do is look for username or user even. Okay. What about let's reverse? So Shift G takes you to the end. In less or VI, if you won and then Shift G, it takes you to the top. you might have seen the slash is a search downwards. If you're already at the bottom, if you're down at the bottom and you question mark, that's reverse search. I find it helpful a lot. So, and then we do a search for pass or password. We actually get a interesting thing here. So here's this website. This will be fixed later. The password is this, and then password for Leviathan. So cool. So that's it for Leviathan 0. This is a quick warm up. I guarantee you this will get a little bit harder soon. But this was pretty easy just to kind of get us going. So we're gonna log into Leviathan 1 here. You'll notice that there's only 7 levels. If you're used to my 3 to 4 hour live streams, I think this one will be a little shorter, depending on how long it takes us to kind of discuss, the answers to these. Maybe an hour, maybe 2 tops, but certainly not going to be like the marathons that Lord of the Root or Bandit was. So, anyways, so now we're in Leviathan 1. We see this check, and unlike what we would do in real life, we're going to run it to see what it does. And maybe even it has like a help. Nope. It asks for a password. We'll just enter random stuff, and it's like, no, that's wrong. So this is the first time I think, I don't know that we did this in Bandit, but we're gonna use a tool called ltrace. If you watched any of my videos for the Sans Holiday Hack challenges, or can't think of one else I would have used it on videos, but I'm a big fan of ltrace. There's two main tools that I like to use on binaries that I'm either trying to exploit or I'm trying to figure out what they do, how they work, etc. before I drop into GDB. One of them is strings. Anybody who does CTFs is familiar with this. So we can do this, and I'll just pipe that to less because we don't have a lot of, I have this bigger, so we don't have a lot of lines on the screen. But you'll see, here's something interesting. Kind of see this secret love E3. So there's certainly some interesting stuff here if you're familiar with hackers. Love, secret. These are all common passwords. This has got a bunch of layout stuff for the code. Different areas for the assembly even. Like .text, .data. I'm starting to learn assembly, so I'm starting to recognize more of what this stuff means. Got some system calls. All right, so that's the strings, but we're going to use ltrace on it instead. And what ltrace does is it kind of shows you what's happening in the background as you go, which gives you a much better understanding of what it's doing, why it's doing it, how it's working, etc. So let's take a look. So here's our password. We'll type in password 123, and we get dropped out. But we see what happens. So we typed in our password. There's some gobbledygook here. And then we see this string compare, or strcomp, however you want to pronounce it. And it's comparing the first 3 characters of our string with the string sex. And it says, nope, it's wrong. So what's happening there? It is likely that if this compares correctly, that something else will happen. We won't get kicked out, right? So let's try that. So we'll put in sex, and then it looks like it's trying to drop to a shell. So here we are. So the string compare worked. It compared sex to sex. It compared correctly, and then it ran system bin sh, which is pretty cool. So who are we? For some reason this doesn't work right in ltrace. So we'll just run it. Boom. Who are we? Now we have UID 1201, Leviathan 1. It's the same we were before, but we also have an effective user ID of Leviathan 2 and GUID of Leviathan 2. Why is that? Well, if you guys remember from Bandit and some, just general kind of going around, or maybe not Bandit, sorry, the Lord of the Root videos, this has this set UID bit set in the execute. So what this means is that anybody who has execute permissions, like us, when we run it, we'll actually run it as if we were the owner, Leviathan 2. This is obviously a fairly scary feature to have. Just randomly set up for various binaries. You have to be very careful when you do stuff like this. But up until recently, there are some famous examples of applications that ran like this. For instance, Ping. Ping needed root level permissions to be able to set up its socket to send the ICMP echo request and receive the echo reply back. So Ping was a set UID application for a very long time. I'm pretty sure there were some changes in the last few years that changed that, but I'm not super familiar with them enough to explain them without leading you astray. So we'll just leave it at that. But it's good enough to know that when we run this, we're actually running it as if we were Leviathan 2. And so if we can trick it into doing something other than what it's intended to do, or in this case, actually what it's intended to do, which is authenticate a user and then run a shell as if it was Leviathan 2, then we can do whatever we want as Leviathan 2. So, boom, we'll run it. There's the password it wants. We're Leviathan 2, and so now we should be able to cat the password for Leviathan 2. And if you'll remember from when we were doing Bandit, all of the passwords for the war games are kept kind of in this directory structure. So Etsy wargame name _ pass, and then the war game level that you're on. So a lot of what we'll be doing in Leviathan is attempting to trick applications or exploit applications that allow us to become the next level up and then read the password for it. That way, if we take a break or pick this up another day or whatever, we don't have to start from Leviathan 0 again. We can just pick up from where we were. So let's go ahead and do that. And here is our Leviathan 2 password. So let's quit out again. We can just go to Leviathan 2. I want to stress something I just said that might have been a little ambiguous, but if you're doing stuff like this, it might be tempting to be like, okay, we are now Leviathan 2 in the shell. Let's work on Leviathan 3. And then kind of build this like nest of shells, like shells within shells within shells of all your different like priv escalations. That's a fairly bad habit to get into. Sometimes you'll need to do that, but really what that means generally on the background is that you're progressing rapidly and you're not really stopping to consider what you're doing or taking notes or even ensure that you're able to replicate this other ways. So it's always good to kind of back out, use the password you obtained, use the other, the new credentials or the new access that you forged. Because what happens if an admin kills like one of those sessions in the line? You don't really want that. So anyways, brief tangent.